Perfect. Hello, everyone. This is Stefan Bernard, the Head of Business Development at Sateliot. Well, first of all, I would like to thank all of our attendees for joining Sateliot's first ever webinar. This will be the beginning of a series. We will be doing webinars on a monthly basis, looking at different aspects of satellite IoT connectivity from space. So today we have here on our panel, Gianluca Redolfi, Nick Sandoval, and Gridios Adomatis, and we're all going to be speaking about the coverage extension of NB-IoT from satellite and the merging of terrestrial and non-terrestrial networks under one unique service. So guys, why don't we start with a round table? Gianluca, do you want to kick it off?
Yeah, thanks a lot, Stefan, for the intro, and again, thanks to Nick, to Jadrius, and to everybody on attending to this webinar. I think it's a big moment in the world. We're going to see it through a few slides, what we are doing at Sateliot, and the same at Teltonika and Emnify. So let's enjoy the webinar, and let's give half an hour of our time to the Q&A so everybody can ask the right questions. Okay, here we are. I'll leave it to you, Nick.
Thank you, thank you. Can I get access to share my screen, please? Stefan, we lost you.
Sorry. So the idea is that we start off with a roundtable of introductions, and then Gianluca kicks off the webinar with presentations. Okay.
Apologies. Well, thank you, everyone. Well, thank you, Sateliot, for having us here. It's a real pleasure. So a little bit of my background. I've been in the IoT space for about 15 years. I'm director of product marketing at Emnify. Been in the role since February, so relatively new still to the organization. But it's definitely a space that I've been in for some time, and I'm really excited about the partnership and the direction we're moving forward.
So I believe that's my turn right now. So hello all. I want to say hello from Vilnius, Lithuania. I am head of the business for asset tracking niche in Teltonika mobility. Also, I'm working here for more than 4 years right now. Also, I'm very happy to be here, and I believe we will have a very nice discussion with you and also with the attendees, which will be able, I believe, give their questions in the chat bar. So, Stefan, you can go.
Awesome. Thank you so much, everyone. Gianluca, we start off with you, okay?
All right, can you see my screen?
Yes, we can see your screen. All good.
Okay, so thanks again to everybody. Okay, so I'm Gianluca Redolfi. I'm the CCO at Sateliot. I'm gonna go through probably five, six slides just to take you on what we're doing and the opportunity that we are having now with this early access program. Okay. So we always say that we are at the brink of a global revolution, basically because there's a big need of IoT connectivity in a massive way at a reasonable price, and it is slowly happening. Okay, we are the unique satellite telecom operator connecting 5G IoT devices of the world from space. So the issue that we are solving is the lack of coverage around the world on connectivity, and the solution that is available now is based on a traditional approach of satellite. Traditional approach is proprietary, which requires all gateways on Earth or requires quite expensive devices when connecting to the satellite, okay? Which makes also it is quite captive because it's not compatible among the different solutions, and expensive because there's no economy of scale. That's what we say is cost prohibitive, and that should limit a lot what is possible in terms of deployment over no coverage from a carrier or cellular telecom area. So our innovative approach is based on the first standard-based telecom operator for space, providing 5G narrowband IoT protocol. So we are developing the first LEO constellation on 5G nano satellites. Okay, it's represented, you can see it on top of it here. And then you see just an example of a truck that is connected to a cellular tower on Earth. And of course, the information goes to the remote operator 5G core. Let's at the moment, let's imagine this truck is going out of coverage of the cellular telecom operator, and it will connect directly without any change in hardware to our constellation. And then the information goes back to our to the gateway that we have from the satellite. It's gonna go back to the core and connect back to the telecom operator. So in other words, in a seamless way, a final user device can have a hybrid connectivity, a transparent hybrid connectivity between the tower and the satellite. So how this happened, there's been a big work during the last 2.5 years inside the 3GPP, which is the organism that is setting the standards around the world. Of course, not done by Sateliot, but by all the key stakeholders of the ecosystem of the IoT, representing basically on each vertical most of the verticals. So on the equipment side, you have Ericsson, Huawei, Nokia, and many others. On the microchips, representing more than 90% actually. So you have MediaTek, HiSilicon, Qualcomm, Apple, Intel, Sequans, Sierra Wireless, and Samsung. And also the telecom space and device innovation, very well represented. In terms of space, we have been by far the most active and with the largest number of contribution in 3GPP. So all this ecosystem inside 3GPP has been agreeing on a release 17, which is a new release, that when installed in the chipset, makes the IoT device, narrowband IoT device, able to connect to the satellite. Our offer is unique. It's the only one now that can allow a massive adoption everywhere and to everybody, because it's based on a standard. It's using a licensed frequency. It's you can use the same device, same operator, dual mode. Price is quite affordable. We are talking about $1 per device per month. It has, of course, a global outdoor coverage, 2 ways. We're not talking about this happening far away from now. We have a date which is set on the 3rd of July, 2023, and everything is happening following the plan to make it a reality for the time. We launched a few months ago an early access program, which we call EAP, that gathers all these players of the entire value chain and offers basically four key aspects: support. So Sateliot supports the technical integration into IoT tech to make sure that the device will work into the Sateliot constellation. It's free connectivity for testing up to 100 devices for all 2023. We say it's easy because you typically can use the same telecom operator SIM that you're using now, because we are signing worldwide roaming agreements with the telecom operators. Okay, so every time we have a new partner, we check which operator they use. If it's part of our agreement, that's fine. If not, we sign an agreement with the new operator, so that it's very seamless and easy to jump on board with Sateliot. And then there's the technical aspect, and we thought about the influential aspect of it, that these partners can be part of the community behind the IoT satellite standard deployment. Okay. So our early access program now it's about to close. Actually, it's limited to 1,000 companies. Basically, the key advantage that you can have early testing integration, as we said. It's an unpiloted solution for the customer, and it can help to have many new cases. We're going to offer also special conditions for testing and commercial agreements, and we think it gives also unique brand positioning for our partners because you can be really, ahead of your competition. So that's in a nutshell what Sateliot is offering. You can always, at the end of this conversation, contact us about the early access program you're interested. And I give it back to Stefan for the next presentation. Thank you.
Awesome. Thank you so much, Gianluca. Nick, the floor is yours.
Thank you, Gianluca. That's very exciting. I'm excited to see your guys' direction for sure. So with that, let's talk how Emnify and Sateliot could really work together and really talk about the future of global connectivity. I mean, you guys heard it right. In July next year, this is going to be a commercial offering from Sateliot, and we're glad to be working closely in having this partnership. So with that said, let's talk a little bit about this is something in Emnify we've always said, one SIM anywhere in the world, right? And it's true to a point, right? But you could grab a SIM and deploy it, whether it's US, Canada, China, India, but it's based on cellular connectivity, right? So as long as there's a cell tower, this is true, but what about those white spaces? So that's really where this is going with this partnership, is you really could cover the whole world. But let's take a step back and talk a little bit about Emnify and who we are. So we're not a startup. We've been around for numerous years. We did a lot of industry firsts, which I'll go through a little bit through this presentation. Some exciting things though to share is, so just to give you an idea of our scale, we've grew 650% in the last 3 years by being able to maintain a 98% customer satisfaction rating. And this is by G2, which is a third-party standard. But let's go back to the conversation about future communication, right? How this is really going to be a game changer. Now, when you talk about global, this is truly making it global, right? Being able to have connectivity at any point in the world, whether it's ocean, whether it's areas where there's no cell towers, you have satellite. It really enhances the conversation about reliability, right? Because reliability often means having multiple areas of redundancy, and this offers that, right? So we'll get into how Emnify sort of does this, but with satellite connectivity, definitely it adds to this without a doubt. Now, a key thing is also that it's going to make it more cost-effective for customers. What I mean by that is, in Emnify, we always work with multiple carriers, and we try to make it the most cost-effective for our customers, so that you use satellite when satellite's the best communication method for you. When it's not, and there's better standards out there, maybe you're near a certain cell tower, then we could leverage that as well. So that makes it win-win for everybody. So global is not something new to us. This just gives you an idea of our backbone. So we actually built the first cloud native cellular backbone, known as mobile cores. And this is sort of like the intelligence of the cellular-based network. Now we made it redundant, so there's multiple points of failure, right? But redundancy in the core doesn't translate redundancy to the field, right? So that's one thing that we've always done, is try to have multiple carriers no matter where they're covered, right? And this model works well when there's coverage, right? When there's cellular coverage. But what Sateliot really allows us to do is blanket the globe, so no matter what, we could guarantee there's coverage in almost any point of space, right? So with that, we could take advantage of some of our advanced processes, and I'll talk us through some of this stuff, like the ability to use automation, like in deployment management, in connectivity monitoring and troubleshooting, integrating to platforms. We really try to make it easy for our customers to integrate to whatever solutions they have, and this is going to allow us to even take this even further, right? Having more connectivity options. Secondly, security is becoming an increasing big topic in this space, with more than 1 billion, and that's with a B, 1 billion IoT attacks in 2021. And this is by VentureBeats. So having a security platform is very, very important, because it's no longer if you can be targeted. The question now is when, and that's a sad reality. So just a little bit of Emnify. We talked about reliability has always been very important to us, and you see that in our model, right? We try to make it very resilient, working with many partners. Sateliot is very unique because they offer a full global coverage like nobody else. We try to make it easy, and that's why we have all this automation technology to really make it easy for customers, easy to deploy, easy to integrate, easy to troubleshoot, and very importantly, keeping it secure. So with that, let's talk about some use cases that we're going to see in the field or in the future when this becomes a reality. Now, this is a great example, fleet management. So this is a big space where you see a lot of trucking, and when it goes from area to area, there's a lot of cellular-based roaming. You could be fine if you're in an urban area or even a major highway corridor, but when you go into remote locations, that becomes a real challenge, especially if you're transporting maybe heavy machinery into construction zones, things of that nature. You have cellular dark spaces, right? And this relationship will make sure that those dark spaces aren't that, right? As long as there's satellite coverage, then you would have connectivity. Now, a very big space where this is definitely going to be a game changer is maritime. So maritime logistics, oftentimes, what happens is when they use cellular-based networks, it's only going to be near shore or onshore, when they go at a port. And oftentimes, because they need connectivity 24/7, they build redundant systems. They have a standard satellite-based communication system, then the cellular, and that takes a lot to engineer. So this makes it way easier where you don't have to engineer all that, right? This becomes a seamless technology that if they're in the middle of the ocean, they have connectivity. When they're onshore, they have connectivity, and they don't have to actually be managing that. That's all happening on the back end for them. Another space that's really big is oil and gas, specifically in the upstream markets. Midstream, downstream, maybe a little bit in the midstream where you have pipelines and whatnot, but really we see this in upstream. So in upstream, you usually have onshore and offshore, and maybe areas like fracking, frack trucks and things like that could be a big play. But obviously, offshore makes a whole lot of sense where you can be using satellite. But even onshore, these locations could often be remote. Sometimes you have cell coverage, but many times you don't. And this is really where it's going to make it easy for an integrator or end user, where they could actually deploy the solution onto an oil field. They don't have to worry about the connectivity and do the engineering normally needed, right? Like, do I have cell towers? Which cell tower do I have there? Which carrier? If not, I have to integrate cell. It just makes it very seamless, so they don't have to deal with all that engineering challenges. Now, another space I see a big market in is actually developing countries. Now, the reason I say this is there's many use cases here. There's a lot of really strong coverage when it comes to, like, say, the US and Europe. But outside of US and Europe, you find that it becomes more spotty when it comes to cell tower coverage. So that's where satellite communications is going to be a very big play. So with that, I wanted to thank you, and I want to thank Sateliot for having us here. The future's bright. I'm really excited for our direction. And with that, I'll bring it back to you.
Perfect. Thank you so much, Nick, for the very comprehensive and entertaining presentation. And definitely the point is today where, mobile network operators often focused on human density as opposed to the potential of applications. And that's exactly where we come into the game. Now for Gedirius from Teltonika, all yours, man.
Okay, so hello all once again, because I see that we have more people here. So today I will present you more from manufacturer side, because we as Teltonika, we are manufacturing the devices which needs a network to pass the data, to pass the location of the assets of personal trackers and so on. So I will give you more information about that. So firstly, I want to start from Teltonika and who it is. So Teltonika, it's a manufacturing company. We have manufacturing plants in Lithuania. Right now we have more than 29 offices in 18 countries. We have more than 20 years experience in this field with GNSS tracking devices. So we deployed more than 20 million devices over these years. And to do so, we needed the personnel to do so, sales, R&Ds, and all others. So we have more than 2,200 employees worldwide. So from Teltonica mobility side, when we're speaking about IoT devices, we have 3 niches there. So we have micro mobility devices. So here I'm speaking about GPS tracking devices, which can track electric vehicles and which can get the data from them or unlock them in some use cases. So these devices mostly are used in food delivery, e-scooter sharing, free-floating niches, and so on. Then another niche is asset tracking. So these are GPS tracking devices with long battery life. So this means that a device with, for example, 1 ping per day right now can work 3 years. These devices also can read Bluetooth sensors data, so we can monitor temperature and so on. And the main use cases also are parcel tracking, container tracking, which is very important when we're speaking about connectivity. And third niche, it's personal trackers. So GPS trackers for persons, basically also with 2-way communication. This means that you can speak through these devices. Also, these devices has buttons. One of them is alarm button. So, for example, when you need some help or elderly people need some help, they can press the button and they can get the needed persons will get their location, and maybe they will be able even to call them and get answer them some questions. So, use cases: lone workers, security guards, also healthcare, and elderly people. I'm sad that I don't have so much time that I could give you more introduction about these devices. So I will dive only into one specific niche. So it's asset tracking, asset trackers. So here is, I will show you a map with predicted growth of asset niche by region. So this is yearly growth of the devices, which is expected to be. So we can see Europe with 600,000 devices per year. And this is very important because we can see the growth over the year, and all our devices, which we are planning to have in the future, and will have 5G narrowband, which is the very important thing when we're speaking about network. And here, I believe we have a problem when we're speaking with the clients and when we're speaking about asset trackers, because these trackers are used also not in very good places where clients are not able to get needed connectivity. So the main problem, also I will repeat, that 85% of the world has no cellular coverage, and by that our clients are not sure that they will have connectivity all the time. They are afraid that they will lose their assets. Also, they are not getting data from IoT in critical cases. Here I'm speaking more about the temperature, for example, when some food has to be in specific temperature and so on, and they have to monitor that very often. So if we won't be able to guarantee that, our clients won't be happy, and we won't be able to give the right solution. So, and with Sateliot, we have the solution. We will be able to guarantee all the time the connectivity. So we have like a zero equipment cost for the final customer, which is very important. Connectivity will be all the time because it will be able to give needed connectivity all the time. More recovered assets in different use cases. For example, when we are putting some asset tracking devices in the cars, so our customers will be able to recover those cars. And low price for connectivity, which Gianluca already mentioned. So thank you for your time, and I believe we will be able to continue with some questions.
Yes, thank you, Guderius. Now the idea is to open up the floor for the attendees. Every attendee can ask questions through the GoToWebinar control panel. You guys have a section called questions, ask questions to staff, okay? I see that they're already popping in. Gianluca, are you with us? Okay. So this one's for you, Nick.
Sure.
So, okay. So the question is, does this mean that through the partnership of Sateliot and Emnify, I will be able to have global connectivity with an Emnify SIM directly?
That is the hope. Yes, so like mentioned, right? Once it becomes standard and you have to have the right hardware for it to work, right? And all the technology has to be in place, as well as obviously the partnerships. But the idea is that you'll have a single device that can roam either cellular or satellite with a single SIM, right?
Okay, perfect. So Gianluca.
Yeah, I'm here.
Okay, awesome. So I have a question that asks about the size of messages that Sateliot's constellation can handle.
Yeah, so we are going to deliver messages up and down to the satellite, up to 250 bytes per message. Satellites goes above every single place in the world for a few minutes. So there's a possibility to send few messages at each passes. So you can aggregate few messages, but that's the ballpark figure that somebody should think.
Okay. Another one for you, Gianluca. Since satellites are much further away from the base station, what will be the requirements of the antenna on the user equipment?
Okay, well, we didn't mention it, but the standard has been based on the fact that no changes to be done on the hardware. Okay? So no change in the chipset, no change in antenna, which basically means you don't need to change an antenna. The antenna that is already in your device, that is able to connect to the cellular non-terrestrial IoT, is able to connect to the satellite. Easy.
So another question, are there any physical changes needed for a terrestrial NB-IoT to work on your system? Okay, that's the same question. So no changes to the hardware. Guderius, this one's for you. Currently, does your customer base often experience a pain of lack of coverage? And if so, is that mostly on Earth or at sea?
So yeah, mostly that is on sea. Also, in the places where we have the mountains, we had a lot of cases where customers wanted to track, for example, cows or other animals. And it's when we're speaking about coverage in those areas, it's very hard to know and get the right information.
Okay. Gianluca, which frequency bands will be used to connect the devices up to the satellites?
So we're talking about standard is on 2 bands, okay, band L and band S. Okay, so our satellites are working on both bands. Okay, so we are dual mode, and that's basically quite open. That's part of the standard that is in approved at release 17 or 3GPP. Specifically on the S band, that probably is going to be the first one to move on. We are at in the band that are around 2 gigahertz.
so 2000 megahertz.
Okay, question to Nick. Local regulatory challenges in various countries is a challenge. While it's really exciting, it's a global connectivity. Do you see any new challenges upcoming which you foresee due to this kind of global presence?
Yeah, that's a good question. I could answer from the terrestrial side, and perhaps I'll bounce it to Gianluca to answer for the non-terrestrial, right? From terrestrial, yes, there are challenges. So there are certain countries that require that makes it more difficult. Like I'll use an example, Brazil. You can't. It's very difficult to do have multiple carriers in Brazil. So there's a lot of workarounds we have to do that, and that's why we only have a single carrier in Brazil. But now, from a satellite standpoint, Gianluca, do you know if there's any limitations on countries and whatnot? Gianluca, I don't know if you heard me, but do you know, is there a limitation from a satellite perspective, communications in certain countries?
Sorry, I didn't hear your question. Sorry about it.
Oh, no worries, no worries. So my question, I was bouncing the same question that was asked to me to get your perspective as well. The question was whether there's challenges from a regulatory standpoint in certain countries, right? So I answered for satellite, for terrestrial, for cellular. Yes, absolutely. There's some challenges. And there's also, you know, the one I didn't mention. There's regulatory challenges around like data privacy, GPRD and whatnot. So we do things like keeping the data within Europe, for example, to handle that perspective. But from a satellite perspective, I wanted to get your take on that question.
Yeah, sorry, I didn't get it before. Look, we have clear processes for each country. Each country is different. So of course there are some challenges, okay, but the process is clear. We already started the process now in more than 30 countries. Probably we're gonna go up to 50 by launch, so next year, and we're gonna sort it out. So it's just a matter of going through the processes, and every single country is a different approach.
Okay. And in terms of the altitude of the satellites, Gianluca, the attendees are quite interested in knowing how far away from Earth they are.
Well, these are probably we didn't mention it. They are low Earth orbit. Okay, so the satellites that are between 550, 650 kilometers from the surface of Earth. So spinning around the globe, they do a full full spin around the globe every 90 minutes and flying at 24,000 kilometers per hour.
Now, of course, battery consumption is a core aspect of any business case, right? Attendees have been asking us, given that devices will now connect to satellites, which are 550 kilometers away from the surface of Earth, how will battery consumption be affected?
Yeah, I can take this one. Actually, as per the standard, again, so which includes all the company I've been showing my slide before, everything is done to optimize the battery. It will have very, very similar battery consumption as it is now on terrestrial. This has never been done in the history, so we're going to be the first one to do it. So we cannot give you records of what happened. It will take maybe some years to have it, but the indication and the test we've been performing with our first satellite are indicating that the battery life is not very drastically affected by this.
So if someone has an existing device using narrowband IoT, is it possible to make that device compatible to our constellation or compatible with release 17?
Yeah, actually, so the only constraint that the device has is on the radio frequency. So if the radio frequency is on the frequency of the standard, then we can share at any time the frequencies that are the standard on the S and the L. There's no reason why it cannot connect with an upgrade of the firmware on the same device to release 17.
Another question regarding the service. How many messages of 250 bytes can be sent whenever a satellite passes over a device?
Satellite goes is visible for around, every satellite is visible for around 4 to 5 minutes. So you can send quite a lot of these messages. So I would expect to 10 to 20 messages for sure.
For Gadrius, a question regarding the maritime tracking sector. Okay, some have said the lack of visibility end to end, not only at seas, but making sure containers are in certain vessels or not, is a big pain. Do you believe the convergence of NB-IoT cellular non-terrestrial network will be a good solution for this pain?
Yeah, so that for sure will be a solution, because right now, in these cases, mostly are used data loggers, which are put on the containers, and when the container goes back to the ground, they are collecting all the information, and they are throwing down that data loggers. So we are wasting a lot of a lot of time and job and money when we are just putting out those devices to the trash bin. So with this solution, with this connectivity, we don't waste this kind of trackers, and they will be able to use in years. So it's very important when we're speaking about this use case.
Okay. One regarding NB-IoT. So terrestrial NB-IoT has been mostly centered in applications and static applications due to the difficulty NB-IoT devices have in passing from cell tower to cell tower. How will NTN NB-IoT support mobile applications such as tracking?
Well, I would say the good part here is, and we call it our solution cell tower for space. The device, since it's a discontinuous connection, are going to see the same network while moving. So it's a way to say that there's a kind of handover between the different towers in space, and this is basically quite positive, because the device can be moving and connected to the same satellite or different satellites in a seamless way. So this issue is solved on this discontinuous connectivity solution.
I think that's key. It has to be discontinuous, right? Because if it's continuous, and that is a challenge, right? But you're right. The NB-IoT wasn't designed to have continuous connectivity all the way throughout and jump from tower to tower and have that seamless connectivity. It doesn't work very well for that. Or if the use case could sustain this continuous communication, and you're sending messages out at X amount of intervals, that's where this really excels.
For you, Gadrius, do you think MQTT will be more beneficial as standard protocol, which is more secure, or you think any other protocol will be more helpful and more swift in communication between device and server using satellite-based NB-IoT connectivity?
So right now, more and more devices and providers are moving to MQTT. So I believe MQTT it's very good. Also, I don't believe that the clients which already are using our, like for example TCP, that they will try to switch because they are happy with that. So I believe in this case we will have the option for clients to pick. But MQTT, I believe it will have the most in the future.
So a question regarding the release. Typically, releases take quite a long time to be implemented. Given that Sateliot's launch date is on the 3rd of July next year, how do you guys foresee the Release 17 implementation?
That's a good question. So congratulations for asking. So what we have been doing, first of all, we are receiving a huge attention from the market. When I say that we are at the brink of a revolution, it's not at all a commercial sentence. It's a reality. Okay? There's an unstoppable willingness to measure everything in the world, everywhere. And the limitation of connectivity is a real pain that most of the companies are suffering. Now, this is also getting into the RF module producers and the chipset producers. And we have been working hand in hand with basically all of them. Some of them they are faster, some of them they are slower, but we are engaged with at least three relevant producers that they're going to follow us and get us to have the right modules by the 3rd of July. And actually, just to mention, they're going to have access, the early access, the partners of the EAP, the early access program I mentioned before, are the ones that they're going to have the possibility of already testing this RF module integrated into the devices.
Okay. Now, how many satellites will be in Sateliot's constellation, and how will that affect the delay or the revisit time of messages being sent and received?
So we have one satellite that we launched last year in March that we're using so far for testing. Another one is going to be launched with SpaceX by this December. And then we're going to have other 4 in H1 next year. So we're going to have in total 6 satellites ready to support the connectivity. This is going to give a delay between 8 to 12 hours. Okay, so this is still for an opportunity for a delay tolerant application, knowing that any investment and any deployment will be enhanced when we're going to launch more satellites. So we have a very clear plan of increasing the constellation. We'll reduce the delay, and the devices and the customer, they don't need to do anything. Basically, they're going to have a higher frequency of connectivity.
Okay. Now, given that Sateliot's value proposition, along with Emnify, is having a unique service with both cellular networks and non-terrestrial networks available, how will network integration happen?
How will networking? So it's going to be relatively seamless from a customer standpoint. They're not going to know that there's integration in that regard, other than they're going to see now different rate plans, and now there's satellite as an option, right, from the Sateliot. So from a customer perspective, it's pretty seamless. There will be obviously different rate plans because it is a different type of system. I don't know if you wanted to add anything about that, Gianluca.
Yeah, actually, I cannot say that much because we're still on discussion with part of the partners on how it's better to have the pricing schemes to make sure that we are really adapted to the needs of everybody, because it's not the same one type of application than another. Okay, so that's again, it's a part of let's say discussion we are starting having with all the partners that we have now. Okay, so, but just the important thing here is that we're not going to be as expensive. I mean, not going to be expensive to a point that you don't want to use it. We're going to be inexpensive to a point that you want to use it and put it everywhere. Okay, and that's the key point. That's what I said before. Our price point is to be at about $1 per device. That will change, of course, based on the usage and probably also of the markets.
Now, obviously, the price of connectivity is very important, but how about the total cost of ownership of the whole solution, right? So typically, satellite connectivity and devices tend to be quite expensive. Why is this different with Sateliot's network or Sateliot service?
Yeah, so one important thing is that at Sateliot, there's a big difference with the legacy of any constellation. We don't want to sell, and we're not there to sell any device or RF module. Any standard RF module with the release 17 is able to connect to the satellite, which basically means we don't need to get to that. And any module that is already in the market with the right frequency, of course, can be used for it. So we're talking about probably a cost that is going from $5 to $15, $20, depending on the module and the needs that everybody has. So very, very affordable compared to any other proprietary solution. Okay? That's the key thing. When you buy an RF module for a few dollars, and then you are an infra-dollar price per month, you're in a very good position to deploy massively.
And I think you said, Gianluca, too, earlier, right? It's leveraging existing hardware, right? So it's not like customers have to really buy anything specialized. And maybe where the confusion is, there's a lot of other than you guys, right, that do satellite, but they do very different type of satellite, and the equipment could, like, let's say Starlink, right? Very different use case. The equipment's extremely expensive, but that's not. But you guys made it so that you can use legacy or traditional, at least I'll say traditional legacy, traditional hardware that's cellular based. You don't need anything special, and that's what's going to keep the cost down dramatically.
Now, an open-ended question to the three of you. I know we've talked a little bit about use cases, but given Sateliot, I mean, the Luca mentioned the delay tolerance at the beginning. What use cases do you expect to be served by, well, the Sateliot's emergence with terrestrial networks, especially in the first year of operations?
Well, I shared a few, right? Like maritime is definitely one that would be a great use case. Oil and gas would be another good one. Depending on satellite coverage, but developing markets, I see that as a place where definitely this could be something that would be very valuable. But it really opens the doors, right? Fleet management. I think Gregorius shared that earlier, right? That's also a play. So it really depends on whether it's white spaces and the type of communications that customers need. Obviously, it's not a play if customers need high bandwidth applications or need continuous communications, right? That's not going to be the perfect target. But if they could have asynchronous communications and it's relatively low data loads, and it's an area where there's really remote locations with no cell towers, that's where it makes a whole lot of sense.
Yeah, actually, we have been positively surprised on the tolerance in delay of many applications. Okay, the fact that it's better than nothing. It's moving so many different use cases. We're very surprised. The ones you mentioned, Nick, and many others, because basically the answer is always, well, it's better than nothing. And if it's so inexpensive, well, I like to have it, and then I know that over time it's going to improve. So we have so many. Actually, among the early access program companies, the ones that joined, we have many verticals. Maybe are over 30, 35 verticals or specific use cases that we were even surprised they existed, and they want to be part of it. So that's very nice.
Yeah, so from my side, I would add also for sure containers, sea containers especially. Also, I would add also wagons, and I believe agriculture also will boom with this, because there is a lot of equipment which need to be monitored, which need to be tracked, and so on, which is also very expensive if that would be stolen.
So question about the EAP. What's the best way to join, and how should I contact the team?
Well, that's very easy actually. Well, of course, you can get to our website. Okay, there's a section for the early access program. Okay, it's called book your free trial now. There's a button, so you just get there and you have the contacts of our specialists. You can always write an email to info@sateliot.space, or you can drop now in the chat your email. I mean, it's very easy. Then we get back to you. We explain much more in detail the program, and then you decide if you want to be part of it or not. Actually, so far it has been. I would say that the convention is almost 100% because it's not binding. Nobody has anything to lose, so that's very interesting.
So in terms of competition, how do you think that you're going to compete with well-established competitors such as Astrocast, Iridium, Inmarsat, Starlink, etc.?
Our position is quite. I mean, there's a belief. The belief is that the standard take it all. We've seen this happening basically everywhere in technology, and we think it's going to happen also here. That the standard is going to be the winner. So that's the game changer. When you can provide basically the legacy and the standard devices, connectivity to satellite. So there's no more investment. Or the cost of the new device is not higher than what it is now. And connectivity is very affordable. Okay, maybe it's not as cheap as the terrestrial, but we are very close. But it's a unique proposition. It's a proposition. It can be massively scaled because it's a standard everywhere in the world. This is the same product. It's produced somewhere on Earth and is shipped everywhere in the world with the same module. Okay? That's very tough to have it when you're not on the standard.
Regarding the go-to-market, will Sateliot have its own SIM card?
The answer is no. Okay, that's why we have Emnify and two other partners. Okay, Emnify is a very good partner of us. We are partnering with the telecom operators, but also part of the early access program, of course, because it's an integration that we need also from them. It's very easy because it's a roaming agreement, so we don't ask any project specifically done or any integration that is costly and requires a lot of time. We have our own core network, so it seems like another operator. Okay, Emnify for sure is hundreds of other operators integrated, so it's like integrating another one. Just instead of working on terrestrial, we work through the sky. So the customer, the final customer on the device, is going to receive the SIM from one of our partners. In this case, could be very likely Emnify. Emnify will own the customer, will build the customer, and will manage the customer.
Emnify will be able to put your logo on the SIM cards.
The two logos, yes.
Okay, so look, that's all for the questions. They have stopped coming in. So if any of the three of you have any comments, this is the time. And if not, I think we can we'll close up our first webinar.
Well, maybe I'll leave the closing word to Gilles and to Nick, and then I can say two words, and then no more questions. We close it.
The only comment I'll have is sort of what I shared in the presentation, right? The future is bright. I'm really excited about this partnership. It really enables our customers, I think. It's going to enable many use cases, and it's going to help customers that may not have traditional means of communications, right? Find a cost-effective methods. This is very exciting, I think.
Yeah, and also I believe it's like a first step to the future when we speak about the satellites and this network, and that's really great.
Yeah, so I want to say just we started more than 2 years ago, when basically this project of release 17 was not at all a reality. We believed a lot from Sateliot that this should happen, okay? And it was not reasonable to have two different completely disconnected worlds from the satellite to non-terrestrial. So now we have in front of us, for the first time in history, the same standard on terrestrial and on satellite. Okay, that's the game changer. We have been the first mover because we've been promoting this inside the PGPP, not only us, but we were, of course, having a big contribution to it. And we were not wrong on seeing that there was a huge need in the market. So altogether, and thanks Teltonika and Emnify and all the partners to believe in this project and to work together to make it happen. And in July next year, it's going to be slowly, nothing is overnight. It's going to be a demonstration that things can be done and the world can be brighter in the present. Thank you. Thanks, Stefan, for
My pleasure. Thank you all, and have a good rest of your day.
Yeah, thanks to everybody. Thanks to everybody.
Thanks. Bye.
It's your pleasure.
Bye-bye. Bye-bye.